College Algebra Exam 2 review. All right, so I have n is equal to 3, negative 5, and 4 plus 3i are zeros. All right, cool. So let's back up a little bit. So we want to find the nth degree polynomial function with real coefficients satisfying the given conditions. All right. So let's see. So the general form, just like before, is going to be, oops, should have put in fx. All right, so we have f of x is equal to a n x minus c1, x minus c2, x minus c3. And then f of x is equal to, so we've already got that part. Now we're going to plug things in. The first one's pretty easy. It's going to be a n x minus negative 5. I finish replacing by putting x minus, and now we're going to be 4 plus 3i, and we'll do x minus 4 minus 3i. Okay, so let's simplify this. Let's do x minus the negative 5, which is the same as plus 5. And now here, we have to do some long distribution to get this one to work. So we are going to say x times x, which gives me x squared, and we say x times negative 4, which gives me negative 4x, and we say x times negative 3i, which gives me negative 3xi, or 3ix. Okay, so let's use a different color. Let's do blue, and now we distribute the 4. So now we say negative 4 times x is negative 4x. We say negative 4 times negative 4, which gives me a positive 16. We say negative 4 times negative 3i, which gives me positive 12i. And then we distribute the, we distribute the 3i. So we say 3i times x, which gives me positive 3ix. Then we say 3i times negative 4, which gives me negative 12i. And then we say positive 3i times negative 3i, which gives me negative 9i squared. All right, let's put this together. Okay, now this negative 9i squared, that simply turns into a positive 9. We have a negative 12i and a positive 12i. We have a positive 3ix and a negative 3ix. And we have two negative 4x's. So we end up with x squared, negative 4x, and negative 4x gives me negative 8x. And we have plus 16, and we have plus 9, which gives me x squared minus 8x. 16 plus 9, which is plus 25. There we go. We put the x plus 5 back on it. Okay, now at this point, now we're going to plug the 2 in. So we say f of 2 is equal to a n x, 2 plus 5, and then we have 2 squared minus 8 times 2 plus 25. And we're trying to solve for the part we don't know, which is the a n. So we say f2 is equal to a n, and 2 plus 5 is 7. And then we say 2 squared, which is 4. Negative 8 times 2 is negative 16 plus 25, which gives me 7 times 4 minus 16, negative 12. Negative 12 plus 25 is 13. Kind of ran out of room there. So what we end up with over here is f of 2 is equal to 91 a/n, and we know that's equal to 91 right there. So we know f2 is equal to, well, now we divide both of them by 91 to solve for a/n, and that gives me a/n is equal to 1. Okay, so now let's rewrite it. So now we have f of x is equal to, I'll plug a 1 in there first, and that gives me x plus 5 times x squared minus 8x plus 25. And then that gives me f of x is equal to just plain old x plus 5, sorry about that, x plus 5 times x squared minus 8x plus 25. And there we go. All that goobly gob, right? All right, so now we are going to find the vertical asymptotes, if any, and we are going to, so we're going to find the vertical asymptotes, if any, and we're also going to find any holes. Okay, cool. Now, first of all, this is already factored, the first denominator, so we're going to set x equal to 0, and we're going to set x plus 4 equal to 0, minus 4, cancel, cancel, x is equal to negative 4. Okay, so we found a couple of zeros. Now, in this case, nothing is going to cancel out, and since nothing cancels out, these are both vertical asymptotes. That one and that one. They're both vertical asymptotes, okay? Because nothing canceled out. Let's try the next one. In the next case, not everything's factored out, so let's factor everything, including the numerator. Now we still set the denominator equal to 0. Which gives me an x is equal to 3. Now the thing is that what gave me x equals to 3, this part right here canceled out with that, leaving me x plus 3, right? Now, since that canceled out, this is no longer a vertical asymptote, this is a hole. So we have a hole at right there. And we wanted the x value of the corresponding hole. If you want to find the y value, we just plug, well, let's just leave it that's right. We don't want to do a limit. Okay, so that's how we figure out a hole. So if it doesn't cancel out, we have a vertical asymptote, and if it does cancel out, that leaves us a hole. Okay. And you can have a combination. For instance, x is equal to 0 here, and we have x minus 3 is equal to 0, plus 3, cancel, cancel, x is equal to 3. Now in this case, though, the x's do cancel out, which means this one, that one's going to give me a hole because it canceled out right there, right? But this one did not cancel out, so this one over here is going to give me a vertical asymptote. Okay. Okay, we want to find the horizontal asymptotes, if any. If they are equal, so this is the same, right? What I mean by that is they're both 2. Right, the exponents right here, 2 and 2. They're the same. So in this case, what we're going to do is we're going to take the coefficients, and that gives us a 4. So in this case, we have a horizontal asymptote. At y is equal to 4. Okay. Now, what about the second one? Well, the next one is we have larger, smaller. And in this case, we can easily see that we have a 3 over a 2. 3 over a 2, which means no horizontal asymptote. Okay, and then we have this last one over here. We have a 1 here, and we have a 2 there, so we have a 1 and a 2, right? So that means in this case now it's smaller on top, and I'm referring to the exponent, and larger on the bottom, and I'm referring to, again, the exponent. And what we have is we have a 1 over a 2. Okay, now what that means is we have a horizontal asymptote. And this one's at y is equal to 0, okay? So 3 different possibilities. If they're the same, it is a fraction made out of the coefficients of the numerator over the denominator, and then you simplify if possible. If they have a larger exponent on top and a smaller on the bottom, there is no horizontal asymptote. If the exponent on the top is smaller than the exponent on the bottom, then you have a horizontal asymptote at y is equal to 0.